I got this comment from a YouTuber, ACDC Just the Best, and he was wanting some information on a Crosley Model 52. And I told him I'd do a video on it because it's going to give me a chance to point out a few things. And down at the bottom you can see that he did find what the problem was, and he sent me the results. So I thought, well, we'll go ahead and do this and see if we come up with about the same results. Before I forget to mention it, I have a link to ACDC Just the Best website in the show more of this video. Now this diagram and information I got from Nostalgia Air, and you can see that it's a Crosley Model 51. I have both radios, a 51 and a 52. The 52 has an extra audio tube to, drive a horn speaker. But the front end of both these radios are identical. So we'll be able to use this diagram to troubleshoot the coil at the bottom that you see with all the taps. Now if you take a look at the first tap, it goes up to what is known as a book capacitor, and then the wire goes over to a grid leak resistor, and that square thing below it is a capacitor. Now sometimes these wiring diagrams are not as accurate as they should be, and what I want to point out here is this capacitor. It's there, and its job is to bleed off unwanted RF before it gets to an audio transformer. If we go to the next page, here's the wiring diagram, and it's easy to find the grid leak resistor and the capacitor that's in the upper left that goes to the grid of the first tube, and the variable capacitor that goes to the antenna, that's the book capacitor, and they don't show the other capacitor. Well, they forgot to draw it in, and here it is. Right here is where it's supposed to be. Now what we're going to do is I'm going to hook up an ohm meter and put the black lead to this point right here, and here's a picture of that connection. The other lead is going to be connected right here for the first test point, and then we're going to go to the next one and so on until we have tested all the taps for this RF antenna coil. Okay, it's time to do some testing. I turned on the meter to ohms, and now I'm hooking a test lead up to the first connection, but I'm also wiggling the connection to make sure I get the best reading that I can. And I called this at 2.1. Next reading, again wiggling the alligator clip. And that one I called at 3.1. Same routine. Giving time for the meter to settle down and to make sure that I've got a good connection. I called that one 4.0. And this one 4.5. Now here's the last one. And this one I called at 5.1. So here are the results that we got, but we're not quite done yet because I'm using rather long test leads plus alligator clips. So I shorted the alligator clips together to see what the meter would read, and it read 0.8 ohms. So I subtracted 0.8 ohms from each of these, and this is what the ohms are now. And when we look at the results from AC, DC, just the best, they are very, very close. Thanks for watching.